Hey YouTubers, Zero Fossil Fuel, and I've been working the last evening reconfiguring the inverted T cell. I wanted to give you a brief update what's going on with the process. I've taken the cell completely apart. You can see that the bubbler came off of the 2-inch T by just taking my 12-inch persuader channel locks and gripping them around the base of the bubbler tube, giving it a little twist like so, and it broke the goop marine adhesive free very easily. So that came off very nicely. Was quite a bit of work getting the rings and the shims out of the cell. I have all of my neutral plates, and my charged electrode has been taken out. And I've numbered them, each plate, as I remove them from the cell, because I want them all to go back in the same order and in the same orientation. I originally had 4 neutral plates in each side of the inverted T cell. I'm going to add one more. Going to go back to 5 neutral plates for my 14-volt input, which will give me 2.3 per plate. That should easily push my MMW rating well over 4.9 MMW. And I expect to come close to, if not exceed, my target of 6 mmW for the cell. So far now, I have taken and carved out 2 electrolyte return channels on the bottom of the inverted T. One on this side and one on this side. Each channel will be utilized alternately by every other plate. And the way that's going to work is I have my spacer rings that have the holes drilled in the top for the gas outlet and in the bottom for the electrolyte return. This is actually going to be inverted when I put the cell back together. I'm going to use the small hole for the electrolyte return, and I'm going to use the larger slot for the gas outlet. And in fact, when it lines up inside the cell, you can see now here I've taken in the single gas outlet channel and I've carved in 2 additional channels side by side. What I'll end up doing now is chiseling that out and creating one large wide opening that the shim will align with when it's assembled inside the cell. Alright, and at the edge of the shim I'm going to be drilling 3 3/16-inch holes side by side, almost joining, and probably cut them through with an X-Acto knife so that I end up with a very large gas outlet at the top of the shim that separates the neutral plates and the charged electrodes inside the inverted T cell. The way this is going to work, however, is every other plate is going to have the electrolyte return. So if you see, I have my hole adjacent to where I've numbered this particular shim. So in this case, this shim would go in like so and align with the channel that's been cut on this side, and my gas outlet tube will be cut offset from where the existing gas outlet is now. The existing gas outlet, this is kind of difficult to hold. Okay, so the existing gas outlet is here, but I'm going to cut 3 new ones here, and the plates are going to alternate back and forth. My electrolyte return for this shim is on this side. The next adjacent electrolyte return will be on this side, and they will alternate back and forth all the way across, going down the stack of neutral plates. The reason for that is to create the longest distance, the longest possible distance that current has to travel in order to jump past the next neutral plate. So in this case, it looks like I've got pretty close to 2 inches that it would have to travel through the cell in order to get to the next neutral plate. We know current will take the path of least resistance, and the path of least resistance is directly through the plates, which are spaced at only 5/16 of an inch. I'm going to have to shave each of these shims down just a little bit to accommodate the 1 extra neutral plate and additional C-ring shim that I'm going to have to cut in order to fit inside the opening of the tube. But that's where I am right now. We're going to continue with the process. I'm going to take and chisel out the rest of this and create one continuous groove in the top of this, and then begin reassembling the plates back into the cell. Alright, I've been trying to think of some clever way to finish out this channel at the top of the T-cell above the spacer rings. And I decided that I would just take the bit that I was using to create the grooves and hack it out of there. So by inserting the shim, you get an idea of what the air channel is going to, or the gas channel, the HHO gas channel is going to look like at the top of the T-cell. And then the holes drilled in the shims are going to have to intersect that. But that should greatly reduce the amount of restriction that is created by those small openings that I once had, and allow the gas to flow out freely. Alright, YouTubers, I've made a startling discovery. I have discovered that when you're trying to cut channels and grooves in PVC, little gadgets like these on a Dremel work a lot better than this guy. I thought this little milling head would work extremely well. You'll notice I've actually dulled it by using it on PVC. Haven't touched any of the abrasive surface on either of these wheels when I was trying to make my channels. And created some really fine looking grooves. Looking all the way down inside for the HHO gas to exit. Live and learn. Alright, just to show you what I'm doing here to get the alignment correct on these shims, you'll notice that where the C-ring splits apart, okay, when I press it together, you can still see the dark line that I've drawn with the Sharpie. And what I'm going to do is I'm going to use that line as I send it down the 3-inch tube of the T-cell to align it with the channel. So I'm going to start with the left side of the T-cell, which is over here. And arbitrarily I'm going to pick the left electrolyte channel to align it with. Like that. So you can see how the opening at the bottom of the shim aligns with the left hand channel going down the tube. At the top, I'm going to draw a couple of marks on the edge of the ring, here and here, so that I know where the marks are that I need to drill the holes in between to intersect with this larger gas outlet channel at the top of the inverted T-cell.